Hello, everyone, and thank you for joining us. Today, we will be talking about artificial intelligence, and not everywhere, but on the public cloud. Between key considerations, use cases, tools to be used, and best practices, we'll cover a wide range of topics. And I'm not alone today. Together with me, I have Aaron. Thank you for joining us.
Hello, everybody.
Let me ask you, Aaron, what's your history with the public clouds?
So I look after what we call enablement of the public clouds. That doesn't mean anything to most people, but effectively it is trying to figure out how to align Ubuntu or canonical products best with what the public clouds are offering. So making sure that our stuff feels as good as possible on the public clouds, and then trying to raise the game of the public clouds in both Linux and open source using the tools that Ubuntu and canonical have.
And I'll give a bit out of some of our secret. It's not secret, actually, it's public, but we can use Ubuntu on all the major public clouds, right?
Indeed.
Now, let's see, how does it apply to AI, and how do we use Ubuntu and beyond Ubuntu on the public cloud? I think by now it's already known that everyone is building a new AI strategy, is leveraging a new LLM, or thinking on how they could benefit from it. In 2022, half of the companies that McKinsey interviewed started using AI, but I would expect that the number grew tremendously with the release of ChatGPT. Yet there are challenges on the way. Whereas everyone wants to do machine learning nowadays, not everyone can do it, because identifying your use case, I think, is the most challenging part. We do hear a lot of organizations saying, I want to do machine learning, or I want to do AI in my company, but I don't know what to do with it. And to be fair, I often say you should not do it. Identify your use case initially. Start with the problem that you want to solve, because otherwise you will get stuck along the way as an organization. You will not get the return on investment that you expect, and you will feel that you fail. But moving a bit beyond this, there is a clear trend to release tools. There is a new tool coming up every day. There is a new LLM, a new framework that you could try out. And they're not necessarily integrated. There is a tooling fragmentation that stops often organizations. And it challenges machine learning engineers, data scientists to move quicker, because they spend more time on integrating tools rather than developing machine learning models. And moving further at security and compliance, this is something that we don't often talk about. I think we're afraid of, because imagine that data is the heart of any AI project. And when you do a project like this, you give access to a lot of data, but then you also create artifacts that give a lot of insight about your organization. So ensuring that you protect those artifacts is crucial. How or building models on a secure environment, from the operating system all the way to the applications layer, ensuring that the models that are deployed to edge devices are secure and they cannot be poisoned, for example, or leaked, are important as well. And then we look at the market. A couple of months ago, there were 200,000 job openings on data science and machine learning on Glassdoor. I didn't look at any other platform, but there's a clear talent gap on the market, which leads to organizations almost fighting for professionals, data scientists changing jobs every 6 months, and then a continuous upskill and challenge on how do you move forward? How do you kickstart your AI strategy when you don't have the right talent, you don't have the right architecture, or you cannot predict or forecast your costs yet? We talk about public clouds, Aaron, right?
Indeed, you've pushed my button. So I think in my side of the organization, there are a lot of reasons that even people who are really interested in Linux and open source, so traditionally quite centric kind of organizations, they still really love using the public cloud with Linux and open source. And so I think one of the reasons for that is that hardware is a real challenge for a lot of people, and there's long procurement cycles. And so particularly when you're getting started in a new industry or a new area, getting the specialized hardware can be expensive and take a really long time. And so it might not fit with the timelines of the project that you've got in mind. And you might not want to spend the kind of money to buy specialized AI hardware up front if you still haven't really proved that use case to your executive team. So when people are getting started, I think that's a clear reason that some people prefer the public cloud. And because that's what everyone's doing at the moment with AI and ML projects, then that's where the overlap comes. And I think we'll talk more specifically about how that fits with the AI ML side of things later on in the presentation. But for now, I think that's a key reason that some people prefer the public cloud. The second is almost the opposite side of that people now have been using the public clouds for quite a while, and they've invested quite a lot in those control planes. And so some people are using a lot of cloud tooling, and adding one more tool to the same public cloud that they're already using can be much easier than setting up a new environment. It can mean that either their compliance is easier because their compliance teams have already said that public cloud is okay, and that can make it easier than doing yet another data center kind of project. Sometimes it can be easier because the organization has committed to a large committed spend with a public cloud provider. And so adding a new project on the same thing, the same public cloud they're already using, can give them economic benefits of reusing that same platform for their AI or ML projects. And then when you go to the next step, there are organizations out there who were born in the cloud. There are organizations that don't even have data centers anymore, and they need a really compelling reason to do something just in an on-prem data center. And so in those sorts of worlds, then clearly they're going to be looking at the public cloud first for any kind of new project. So I think when you're talking about how these pieces fit together, all of these things kind of fall together in a bit of a spectrum. If we go to the next slide, I think you have different things that people mean when they're talking about AI or ML on the public clouds, and some of it's extremely overwhelming. I went and looked around at some of the AI parts of the major public clouds, and you're just talking pages and pages of services. And if you're not in this space, that can be quite hard to understand. So on the left here, I have the ready-made AI ML services that some of the public clouds, or most of the public clouds, offer. And here are some things that you may not even think of as AI or ML. I mean, I'm sure, Andrea, you do, but a lot of people wouldn't think of these as being related to AI or ML. And things like translations and things like image recognition, or how you build your chatbots with a more easy to use platform. Some of these things rely on AI and ML, but they aren't your immediate sort of use cases that jump to mind. Generative AI is a little bit more towards that, and I think that's just because the media talks about it being AI when they're putting it out there. But there are a lot of pieces here that the public clouds use to make a service available to you. And then on the other side of the spectrum, you have those tools that are really designed to help you take an idea all the way through from conception to production, with a lot of ability to customize it on the way through. And I think it's fair to say we'll be spending most of our time on that right-hand side of this picture. And that's not because those ready-to-use solutions aren't good or useful or the right answer for you in certain circumstances. It's just that they're very specific. And so if what you're trying to achieve is to translate a whole bunch of text, then you're probably better to go out and look at what the translation services are that both your public cloud provider offers and what the market as a whole provides for translation services, as opposed to looking at the entire spectrum of things you could do with an AI ML tool if you don't have any broader interest in going on that journey. And I think a lot of these things are a spectrum again, and you're as a company likely to move along this. And so there are many companies or organizations that will start with a specific use case, and then as they need to dig into that in more detail, they might need to customize it a bit further. They might look to reduce their costs as it becomes more crucial to the organization, and they're doing it at much greater scale. But as they do that, they want to get more control over their infrastructure and dig deeper into the way that's actually working behind the scenes. Is it possible for you to tell us a little bit more, Andrea, about how that organization journey looks for a lot of the people we've worked with?
Yes. I'll move quickly towards next slide to say that, but also I would like to add, Aaron, that I think you pointed out very well that there is no right or wrong answer when it comes to ready-made solutions versus tools where you can build your own solution, but rather it depends on where you are in your AI journey, and also what's the scope that you do. If you're a small company that now it will use only one use case specifically for the next 3 years because of the company size or the activity, then maybe it's worth considering a ready-made solution that covers your needs rather than investing time and skills and resources in general to build your own model. But at the same time, if you're an organization of 20,000 people, it's very likely that you will have more than one project. So whereas you're likely to start with a ready-made solution, you will scale towards the idea of building your own solutions, optimizing your existing models for your use case, for your needs, uh, because because of really the wide range of applications that we have. Like even if we look, for example, at the telco company, there are so many departments where you can apply machine learning, from having self-organized networks on the radio side to having smart chatbots that help with support, to maybe having personalized offerings for users when it comes to their subscriptions. Almost any department can benefit from, if not all of them, can benefit from artificial intelligence, and that's when it becomes interesting to be able to build your own solutions. Now, going back to the AI journey, because I derailed a bit, it's really a journey. Organizations start, or they should start with a problem that they have, and then once they start looking at the problem, they do an initial exploration. It often happens on a laptop or on a public cloud, but on small instances, I would say. And Aaron, correct me if I'm wrong, of course. But it doesn't need a lot of compute power to get started. You don't need the most powerful instance on a public cloud. You don't need the most powerful laptop. You don't need a GPU, of course. And data scientists, developers in general often choose Ubuntu to run it, but of course that depends on your expertise and your own preferences. However, as the project grows, a wide range of tools are going to be added. From Jupyter notebooks, which are famous for writing Python code for and building models, capabilities such as repeatability or reliability of the project become important. You stop working in a silo on your own. You start sharing your work with your team, for example, or with your coworkers, such that you can experiment better. And that's when also the need of having more compute power appears. From having a small instance, for example, on a public cloud, you go towards larger instances with more power compute, with more GPUs, maybe with different architectures as well, depending on your needs. And once the idea is validated and you understand both the success criteria as well as the pitfalls or the improvement plans, you move towards scaling your project. That's when having a long-term vision comes in place. That's when probably having ready-made solutions doesn't fit anymore as well, because you have more than one project. You have 50 data scientists, for example, running on an MLOps platform. Here we have Kubeflow, but whether it's Kubeflow or SageMaker or Vertex AI, we're going to talk more in details about it, and actually how you should consider them. And the last part of the journey, which is the most important part, no, yeah, it is. Because if you don't have your model on an edge device, you don't benefit from it. It almost feels that there is no real result. Imagine you're building a smart city, and one of the use cases was to have automated or intelligent alerts when accident happens from the surveillance cameras. If that model never makes it to the surveillance cameras, is your project successful? Does it really give any return on investment? So the deployment part is also interesting. And how do you deploy to edge devices from a public cloud or from a hybrid cloud scenario? It's often a question mark and it's challenging. The tools that you need, the way that you package the models, the way that you secure everything is interesting. But then, sorry, Aaron. Yes, I saw.
I moved. So I was just interested there because to me it sounds like when you're talking about scaling, you're not talking scaling like people talk in an infrastructure sense around the size of the model or the problem as much as the size of the team that's working on it and the ability for those people to collaborate.
It's interesting because it's I think there is a clear correlation as the team grows and the number of projects grows as well. Also, the compute power and the infrastructure underneath grows as well. You need more compute power, more GPUs, but also you need an environment that enables collaboration. It isolates because imagine you have a project that uses the financial data of your company. You don't want maybe all your data scientists to have access to that kind of data because it's highly sensitive. So maybe you have a squad of 3 people specialized on dealing with highly sensitive data within your organization. And these are just capabilities that you do need when you scale your ML capabilities within an organization. So it's true the infra grows, which is naturally, but also then you have you have capabilities that need to enable collaboration and at the same time optimization. For example, you mentioned the model size. Often we aim to have smaller model sizes because you deploy it to a surveillance camera, which is very small. It doesn't have a lot of capabilities, doesn't have a lot of memory or anything. It's very small, so your model needs to be lightweight. And then that's when it comes in place. Optimization frameworks, for example, or hyperparameter tuning capabilities, the way that you package the model for specific devices as well, which we'll not cover though in this webinar, because otherwise we'll be here for the next 2 hours. Did I answer your question, Aaron?
You did. You can carry on.
Yay! I'll move towards because I already mentioned a lot of tools, and when it comes to AI with machine learning in general and AI projects, I think there are 3 important pillars that we will talk about. On one hand, you have the models. You use the data to build machine learning models. And in the LLM boom, there are a lot of models already that are ready made. And then how do you use them is a question that we often get. But then you also have tools because even if you do have a model, you want to optimize it. And beyond that, it's very important to remind everyone that you don't only have LLM use cases, you have traditional machine learning use cases that you should not ignore at all. Like predictive maintenance is something that comes up very often in discussions with organizations from different industries. So it adapts. But then you also have different frameworks, different images or pre-configured images that you can use. That will not make it any longer. I'll move towards the models. And it's very interesting. Through the entire presentation, you will see that we present different angles. We have open source models such as Mistral AI, which has been around for quite some time, but then you have also, and we see a trend in, for example, the clouds building their own LLM, which is of course is optimized for their hardware. I would assume that Palm works much better on Google because that's where that's how it's been used and built. But then you also see a clear need to enable more and different LLMs on different clouds. And I'm thinking now of Bedrocks, who really gives you access on AWS to any, let's say, cool thing that you have nowadays on the market, right?
Yes, I think that's right. There's a pretty clear sense to me anyway that the public cloud providers want to give choice to customers. I think we've seen even with Microsoft originally was one of the big investors in OpenAI, but then they've since made some other investments in companies around different models. So I think we're seeing a clear trend that the public cloud providers see this as an area that is popular with customers, and I suspect that's because customers are excited or they've been reading about these in the tech press, and so because they're popular, they want to try all the different things, and getting people to try new things is a great way of getting people to try new things on your public cloud. And so I suspect that there are some pretty obvious economic reasons that the public clouds are doing this, but I also think that it's not yet clear which of these organizations making these models are going to be the winner in the long term. And so hedging bets across those is a sensible thing for the public clouds to do as well.
I might join our debate, but I don't think there's going to be a one answer for all. And it's a question that we do get from organizations or customers often is, what LLM should I choose? Like, what's better? Is it Palm or Mistral? My answer is depend, and our answer is it depends. It depends on your use case, your data, where you are in your AI journey, and that's very important. You should not, in general, think in any IT project, but especially when it comes to picking your model, you should not do it just because someone else did it or because you read in the news, but rather on one hand look at the use case and if the model is optimized for your use case, but also consider experimenting a bit, going back to where you are in your AI journey. Maybe you want to try 3 different models initially to see which one works better and based on it to choose, because there is no such a thing as an answer that fits it all. And I doubt it will be in the near future. It's a very quickly changing industry. If you go on holidays for 2 weeks and you come back, you might feel a bit lost. I'll have to say this. And I'll move towards the tools because that's also a very interesting topic. We see tools coming up every day. We see tools repurposing for AI, and here I really think of, for example, Postgres. It's known for being a SQL database, but nowadays they have a lot of add-ons for machine learning. They have Postgres ML, they have the vector database part of Postgres. But looking also at the MLOps platforms, which we see most used, each cloud offers their own. So you have Vertex for Google, SageMaker for AWS, you have Azure ML for Microsoft, but you also have open source solutions such as Kubeflow, for example, or MLflow for some capabilities that are being adopted. And which one you should choose? Again, it depends. There are a couple of key considerations. What's the cloud that you are using? What is the expertise that you have? Because if you've been using AWS for 5 years, I would question if it's really wise to move toward to, I know, Google, for example, just to use your MLOps platform, because it really involves moving and upskilling someone on that area. But then also there's a question on where does your data live? And based on it, maybe you should choose the right platform. But also, what are the use cases that you're looking for and how advanced you are in your AI journey? Do you want a solution, for example, that is modular, or do you want a solution that is almost ready to build, ready to be used, and that's it? Another thing that it's important is to look at the Kubernetes distribution that you have and the compatibility, because all these are cloud native applications. The compatibility between the case distribution that you use and the platform is also crucial. And I'll have a couple of more considerations in a couple of slides. But I'll move also towards the frameworks, and there are plenty of them. Again, you see open source ones such as LangChain that enabled and almost I think it accelerated the LLM revolution or the Gen AI new industry, the Gen AI industry that has been defined recently. But then you also have frameworks and images that are pre-configured on each cloud. DLAMI or the Deep Learning AMI from AWS, the Deep Learning VM from GCP. On one hand, many of them are based on Ubuntu, but then on the other hand, they're also an easier and faster route to get access to an environment that works fine. And there are questions on, is it a way to run machine learning in production? I would easily say no, because of security concern, because of scaling capabilities, because of monitoring capabilities that I'm not sure if they are where they should be when you run in production, because you don't want an accident to happen and your camera not to alert it and people to have your city blocked just because the model is outdated and it has not been monitored. But at the same time, it's a great way to get started. If you want to start building your own models and you don't want to spend hours and hours into configuring an environment, that's the way to do it. And it's easy, it's out there, it's available on all major public clouds. And there's nothing to stop you. And it's important that you have better visibility on how security is. You can easily migrate. all these environments invested a lot also on offering migration paths. If you start on a DL-AMI that uses Jupyter notebooks, for example, then you can move towards a more maybe complex, but also an environment with more features such as that uses Kubeflow or SageMaker, for example, because it's still at the end of it, at the back of it is Jupyter notebooks that you are familiar with. So the journey will not be that difficult, I would say.
Yes, and on a lot of the clouds, we call these frameworks, but a lot of the time this is a virtual machine image that you will launch where it is effectively perhaps an Ubuntu instance with a bunch of stuff installed on it from a bunch of locations. And I think in a little bit like you say, but a little bit like containers, that's great for having something that is up and running and has everything that you need at your fingertips. I think that always is a double-edged sword, whether you're talking about this or more broadly any kind of pre-configured images. You need to make sure that that has a security story, or you know how those are being updated and maintained over time, and that the source of all of those pieces of software is somewhere you're happy with, etc. So I think that piece is much easier if what you're using is an exploratory tool, and it's a little bit different when you get into production, where you might want a little bit more certainty around each of the container images, for example, to make sure that you know that they're coming from a place that you trust, and that there is a security story, that they're being updated on a regular cadence, and all those kinds of things. Whereas that might not be seen as quite so important at those early exploratory stages where you're working through playing with those things.
I think you're nicely making the transition to our next slide, which is really around what are the key considerations. And we already touched upon a lot of them. We talked about your cloud expertise and how important it is. What's the cloud that you're familiar with? What's the cloud where you're storing your data? Because if you're storing all your data on a cloud, you don't want to move it towards another cloud to train a model. It's costly, it's timely, it's completely inefficient. But then also, if you have 100 solution architects that have been working on cloud, you don't want to ask them to learn everything about the other cloud, because whereas that might be helpful in the long run, it will delay your AI projects with, I'll say, at least 1 year, and then in 1 year a lot of things can happen. One thing that we didn't talk a lot about, and I often think organizations forget about it, is your long-term vision. Where do you see your project in 5 years? Okay, you start now on a cloud, for example, or you start now with a pre-configured image, but where are you going actually? And having a clear strategy. Do you plan always using a cloud because you're a cloud-first organization and it's fine? Or do you have a multi-cloud strategy? Do you have a hybrid cloud strategy, for example? All these factors influence the tools that you're going to choose, the frameworks that you're going to choose, even the LLMs that you're going to choose, because there are also restrictions, or there are constraints that you have to bear in mind. If you want to have, for example, a hybrid cloud scenario where you experiment on a public cloud, but then everything that runs in production is on-prem, this is something that we see often happening, then you might want to have tools that give you this flexibility, or that you have. But at the same time, if you have data staying or living on different clouds, you might consider, do you want to have different environments for each of them because you never need to connect the dots, or do you need a platform that can run across all of them? And last but not least, I would also look a bit at the Kubernetes layer. And we didn't go a lot in detail this time on how important K8s is, but from optimizing the resources that you have by using schedulers to actually being able to run platforms on a cloud, MLOps platforms on a cloud, your K8s layer plays a crucial role. And what's the Kubernetes that you plan using? How do you use it? How do you use it as an enabler to optimize your resources is very important as well. And I feel like we enjoyed the topic because we are talking way more than we expected. But I'll move towards the machine learning lifecycle. And it's very interesting to, as you probably already figured it out, it's interesting that you can run the entire machine learning lifecycle on a public cloud. Often organizations store their data on a cloud, which is nice, but then you can fetch the data. Assuming you have a smart city use case, you do want to take the data from all the sensors. You want to take the surveillance data, which can run, and then you can engineer the future features. Sorry, not all the data that you have is going to be useful. And it's very important. You should not try to use all the data that you have, because nowadays we collect tremendous amounts of data. Understanding which is the data that is useful for your use case is important. And these are things that you can do with tools such as uh, Spark, for example, for data streaming or for big data use cases, but also you can feature the data with tools such as SageMaker as well as Feast if you think of open source solution. Once you have the features, you know which part of the data is useful, you go towards building a model, training the model, testing the model. And it's important to say that this is an iterative process. You don't do it once and then you never look at it again. And you don't do it once and get the successful recipe. It's a lot of trial and error. It's a lot of frustration often as a data scientist, but also a lot of reward once you figure it out how it works. If you think of having a LLM use case, you might skip these phases, but instead of training the model, you want to optimize the model on your use case, and then you need a couple of other capabilities because you still need to understand what's the data that you use. If you build a chatbot, where do you store the data that optimizes it for your own queries or your own questions? Then you store the model as well, and there are different ways to store models. There are different places to store the model, and it's important to again bear in mind that you don't do it only once. You store a model has many versions, and you should consider and you should have a strategy on how do you plan updating the model, how do you plan maintaining the model, because it's not that you build it once and never look at it again. That will fail. And last but not least, you deploy the model. Deploying models from a public cloud to edge devices is possible nowadays. It's quite interesting to see how quickly it evolved as capabilities, but it is possible. And I might be wrong, but recently, for example, Azure had an IoT Edge AI announcement that was also interesting, and it might be interesting for you to check it out if you're in that stage of the life cycle. And I'll quickly move towards MLOps and what it is and how it helps. Well, whereas we talked a lot about the initial phases of your AI journey where you don't need MLOps, you're just playing around, having a pre-configured image is easy. Once you move towards scaling your projects and having needs to have reproducible, maintained projects and models as well, you need MLOps, which comes from machine learning operations. I always define it as DevOps for machine learning. And it's really the practice, I would say, that enables you to build models in a reproducible and portable manner. In Canonical, we have an MLOps architecture that is really plug in, plug out. It goes back to the idea that there is no such a thing as a solution that answers all the use cases. Depending on your use case, your need, where you are in your AI journey, you might need different tools. Maybe you need Superset for data visualization, or maybe that's something you don't need completely because that's not what your use case is about. And having it as a plug-in, plug-out architecture gives the freedom for organizations to adjust it based on their needs. Now, of course, if you're, for example, in initial phases of your AI journey, you might don't want something that's modular. You might want something that's more out of the box because it's easier to get started. And capabilities such as simplified deployment or simplified upgrades are important, especially again when you run at scale, because you don't want to manually upgrade a high number of nodes. And we have observability capabilities as well, which are interesting because on one hand, maintaining and monitoring your model is important, but then also monitoring the infrastructure where your model lives, where your model is developed, is no any different than monitoring the infrastructure that we've been doing it for years and years now. It's just a new layer on top of the stack, but you should think of it as having the same needs as any other tool that you're using within your organization, monitoring it, having backups, being able to restore, sharding, they're all needed, especially when you run in production. And this is a slide that Aaron will say that it's bothering because it's not perfectly aligned, right? But it really showcases, on one hand, the complexity of the AI landscape. I don't have all the tools here, and we have open source in our DNA, so I showcased a lot of open source tools, but they cover the entire machine learning lifecycle, from storing the data to streaming the data, building models, as well as deploying models in a secure and reliable manner. You can do it all with open source. Is open source the answer for you? It depends, right? Depends on your needs. See,
I think
Aaron wants.
I think one of the interesting things that I take away from this slide, which is a little bit logo soup, is that you look at it and on the one hand, all of those things are open source projects, right? They're all things you could go and sort out yourself. But to me, the key takeaway when you talk about this, Andreea, is that there are so many pieces there that have to work together in harmony, and that if you're an organization who's trying to understand this area and might be new to Kubeflow or MLflow, which you thought was a thing, and then you find out it's actually 50 things. I think one of the hard things as an organization is, okay, well, how do I make sure that all of these disparate projects meet my requirements in terms of regular security cadence, assurances around how they integrate together and how I get access to them. And so I think this, in a way, similar to how packages were a key reason that distributions emerged back in the early 2000 1990s, that sort of area. There is a clear reason here why it might be valuable for an organization to use someone like Canonical to help them get access to open source, rather than going and getting each of those pieces themselves and trying to put it all together.
I think you're right, and I think you're nicely again transitioning to my next slide, because whereas the landscape is overwhelming, it's also nice that it's open source. You can try it out on your own without worrying too much, as long as you don't run it in production, right? You're curious about the vector database that Postgres just built. There is nothing to stop you to try it out. You go on our website, or you go on the upstream website. You deploy it on your laptop or on your mobile device. It ensures
We lost you
the.
for a second there, Andreea, I think, unless that was
Oh,
just me.
can you hear me now?
I can hear you perfectly fine, but you were talking about how you can get access to Postgres at the outset and use it for your initial sort of pieces, and then I think I lost you from there.
Yeah. So you can just use it from the upstream, for example, for your initial work, but then in order to ensure the security maintenance, the integration of all these tools, you do need someone, or it helps, it simplifies having someone to distribute it, because on one hand you ensure the security maintenance, but also the integration between these tools. If you look at the number of logos, or the soup logo, to quote you here, it can be overwhelming. You need an army of people to test it out, to secure it, and so on. And I'm not saying there are not organizations who do it. They are, but usually they are very, very advanced in their AI journey. So they've been doing AI since 2000. Now they know it all inside out, and they have a lot of experts. If I look now at how many openings are on the market, I think it's a bit difficult to do that as well. And going back here, I think you nicely transitioned. You can run your entire AI journey with open source, regardless of the environment. You can start on your laptop, you can start on a public cloud, and you can scale. It gives you a couple of advantages, but also it ensures the security. I think the security is the most important part of it. It ensures the security of your infrastructure. And similarly, how organizations care about the security of their operating system, about their Kubernetes distribution, about their bare metal solution, they should care about the security of the applications that they use for building or for developing and deploying models. There is nothing different. And I think the only difference is that there have not been many attacks yet, so no one is very panicked. But being also mindful of time, I'll move towards on how you can run AI on public cloud. Very important, I think. First, it all starts with the operating system. I think by now it almost feels like it's natural. You know you need an operating system, and ensuring that it is secure, it's important. We can easily talk for hours and hours about Ubuntu Pro. Aaron, I think you do have some webinars on Ubuntu Pro, right?
More than one.
And how it actually enables you to have a secure operating system, but that's not enough. You don't only need an operating system to build and to run AI in production. Your infrastructure needs much more than that. You need a Kubernetes distribution, and whether it's our own distribution or EKS or AKS, you should firstly ensure that it is secure, but also that it integrates and it supports different tools such as an MLOps platform. Again, whether it's SageMaker or Kubeflow or Charm Kubeflow, looking at it as really a tool to enable you to scale your AI projects is what it should be. But then you don't need an MLOps platform right away when you get started. When I got started with machine learning, first of all, I don't think we had MLOps platforms back then. But regardless of that, it's also, I was looking for an easy solutions like the deep learning images or the deep learning virtual machines that different organizations have are just a door that you can easily open in a couple of commands, and they're great to get started. Now there are capabilities that we didn't cover at all, such as confidential computing for highly sensitive data and how it enables highly sensitive data, or instances that use FIPS. Correct me, Aaron, if I'm wrong. I'm not. For specific industries, those are also things that you should check it out. Don't invest 1 year in your AI project or on a public cloud and then realize that you're not compliant, you're not secure, because it would be very difficult to reverse it back. Rather, have the checklists initially, and based on it, build your infrastructure from the operating system to the application layers, and take it step by step. Don't get overwhelmed or scared by the soup of logos or by the many tools that you need, but rather grow your capabilities as your projects grow. That would be my 2 cents, as well as the compute power. I'll have to say, don't start with the largest instance out there just because you know that's what you will need in 1 year, because you do have capabilities that enable you. For example, spot instances are a cool thing that helps, especially when you do model training.
You're stealing my next slide.
I'm sorry.
So in terms of why specifically you should look at the public cloud for your AI and ML projects, I think there are some out-of-the-box solutions we already talked about. So that's up there in the top right. I think there are some access to hardware points that we talked about right back at the beginning, and I'm going a bit quickly here because I'm conscious of time. I think security and compliance is a really interesting one, because intuitively a lot of people think that having something on premise or in a physical data center with, you know, guards at the door feels like a nice secure thing in the first place. And it's a bit mixed. It sort of depends on your environment, how you've integrated things, and what sort of policies and processes you've put around your cloud estate. I've seen a lot of companies that are doing a better job of lifecycle managing new instances on the public cloud than they did for their legacy estate, because they see it as a good opportunity to do better practices for new environments than they did historically. But also there are some advantages in the way that particularly Ubuntu partners with the public clouds. And so as an example, we make new images available to the public clouds that include all our security fixes all the time. Yeah, and then you can pull those into your pipelines. If you're using the Ubuntu Pro that Andreea talked about before, it's going to give you more security patch coverage. And so again, that can just be something that you build into your pipelines. And then the images that you pull out of that are going to have that security baked in before you start using them. And so there are some options to integrate those pieces, and most of them are possible already on your on-prem or data center estates, absolutely. But because of the ways we've integrated with the public clouds, for some companies particularly, they can be easier on the public cloud than they are on-prem. I think optimized usage is a really interesting point, and that does talk about things like those spot instances. Spot instances, I'm guessing, would be familiar to a lot of the people who are listening to this because it is a public cloud webinar. But a spot instance is effectively the unused capacity of the public cloud at a massive discount, sometimes up to 90% of the list prices of those instances as a discount. But the downside of them is, and it does vary by cloud, but the downside is that you can often be interrupted in your workloads or have those preempted. And then what that means is that wherever you are up to is then terminated. So it needs to be an interruptible workload that is not time sensitive. And so something that you can do over a long period of time, but have it interrupted now and again, and then carry on roughly where it left off, can well be worthwhile if you can get a discount like that in the way of doing it. Flexibility is something we talked about before. That's the ability to use different instance types or different levels of compute cost effectively for the workloads that need them in a way that you can't do when you're provisioning for a sort of 3-year hardware replacement lifecycle or whatever. So if you've got to try and predict what your AI ML requirements are going to be 3 years, 5 years in advance, that's really hard, particularly as things are changing all the time. And so being able to test out the new AI accelerators or whatever that each of the clouds is pulling out and see if for your workload that works better. That's something that you can do when you're paying on an hourly basis, but you can't do if you're buying years in advance. And then scalability is the next point there that's related, and that if you need to scale up, particularly if you're using something that is horizontally scalable as your underlying platform, then being able to scale it on the public cloud and having infrastructure on demand can be hugely powerful. And that's, again, one of the classic benefits of using the public cloud. You'll trade away some of those things often for bigger discounts, but still the starting premise is that the public cloud is going to give you more elastic demand, more elastic provision than you can get in on-prem data centers.
One thing that it's interesting, and correct me if I'm wrong, Aaron, is also that the public clouds have always been pioneering, giving access, for example, to the latest hardware. If I really think of Blackwell that NVIDIA just announced, I think it's already available on one of the clouds, right?
Yeah, I think that whole area is really exciting, and it's an area that we work closely with the public clouds because many people choose to use Ubuntu for their AI and ML workloads. And so that gives us a really good opportunity to make sure that Ubuntu is great on all of the public clouds, because again, we have a great presence on all of the big public clouds. And so we are working with them to try and make that hardware usable on all of those public clouds. And that's a really neat kind of collaboration. It's something that if you're an end user organization, you wouldn't have the same scope to be quite so pioneering and work with all of those suppliers to get your latest hardware and latest accelerators or custom accelerators working. But because of the scale of the hyperscalers, then there is the ability to work on pioneering hardware and then make that available to people on an hourly basis in a way that isn't possible if you have to do all that investment just for your company or your organization.
I'm mindful of time, and I think I'll move here because you already mentioned about the security maintenance on and how Canonical enables it on the public cloud, which is important. Then we already talked about how we integrate the tools and how we integrate the solutions. It's also interesting to mention, we didn't touch much on this, but we also integrate with a lot of the capabilities that the public clouds have. If you have an Active Directory on one of the clouds and you want to use an MLOps platform, there is nothing to stop us to work together. And that's also a different layer of the collaboration. Or if you use an EKS and you want to have a kubeflow deployed on top of it, there is nothing to stop you as well. It's It's also integrating the tools, but also collaborating with the clouds to ensure it works. Then looking at the costs, I think the predictability is interesting. And last but not least, since Aaron, you asked me a couple of minutes ago or you mentioned actually, about the importance of collaborating with the companies such as Canonical around support, whether you want enterprise support or you want managed services, because again, you don't have enough skills in-house yet to manage your MLOps infrastructure. We are here to help you out, and we do have a webinar that we had recently on managed AI and how do we manage it, including on the public cloud. Actually, we do have some interesting use cases out there. And since we talked a lot about it, how do we get started? You might say, said, hey, you've been interesting, but I want to try it out. And you can, whether you go on the marketplace to get the appliance and you deploy it quite easily, or you go on our documentation to do and follow our deployment guides. And here you have different options. You can start an instance and use microkits, for example. You can just go ahead on the Kubernetes instance that you already have running. Or last but not least, you look for enterprise support or managed services, whether because, for example, you've been using the upstream project and you want to start deploying your models in production, or because you're looking for an MLOps platform that fits your needs, and our platform does it, there is nothing to stop you. This would be the 3 quick answers, and I like that they're actually laid out exactly like the journey that we discussed about.
Yes, I think
Yeah.
that there's a lot of different ways you can get started. I think they're all more compatible than you would normally see, because the underlying tooling is similar across all of those different ways of doing things. So none of them are going to get you stuck in a way that is then not useful when you go and try and do it again somewhere else. It's also worth contacting us, because if you're interested in having a relationship around a managed service or enterprise support, it may be that we can transact that or make that possible through the public cloud marketplaces, and maybe be able to use that to help you with your cloud discounts, etc. So get in touch. We're happy to talk about how we might set that up for you and make sure it ties into your existing infrastructure on the public clouds.
Thank you everyone for the images as well, and we are happy to get your questions. I would say thank you for staying until so late. Whatever I'll say, whatever question you have, we're happy to answer it, whether it's about clouds or AI or both of them. And also thank you, Aaron, for joining me.
Thank you for having me.